Good evening, students. Uh, Today, I hope you're very well. Today, we will going to study or look at some CBSE PYQs from our chapter, which is solutions. Okay, we have already covered its theory and its NCRT exemplar questions, and today we will going to see some CBSE PYQs, which the CBSE has covered in its examination. So, okay, let's start. Disclaimer: the images, text, and other material used in our presentations are for educational purposes only. We respect the intellectual property rights of original creators and owners. If you are the owner and have any concern or issues, please contact us at sathee@iitk.ac.in and we shall remove the content immediately. Please note that the parts of the content may have been generated using generative AI, which is experimental. Okay, so let's start with the first question, which is an MCQ type question, and we have covered this question from the NCRT section 1.3.2 in the chapter solutions. So the question asked is that the value of Henry's constant KH is. Okay, so from the given option you have to correctly match that the value of Henry's constant, that is KH, is related to which option. So the four options given are: greater for the gases with higher solubility, greater for gases with lower solubility, constant for all the gases, or not related to the solubility of gases. Okay, so these are the four statements given regarding the value of the Henry's constant. You have to find the correct statement or correct relation given in our option. So you have some time, go through it, think about it, and then we will continue to its correct answer. Okay, so let's see. So for this given question, the correct answer is option B, that is greater for the gases with lower solubility. Now, if you talk about Henry's constant, we covered this in Henry's law, which states that the solubility of a gas in a particular liquid is directly proportional to the partial pressure of the gas which is above the liquid. Okay, so this is the definition or basic definition of Henry's law, which says that if a gas is either soluble or not in a liquid, the solubility of that gas is depending upon the partial pressure of that gas above the liquid. And if you want to give the formula for this, it will be given by P equals to KH time chi. So P here is the vapor pressure, KH is Henry's constant, and chi is representing the mole fraction of the component. And this is the equation 1.11 in our chapter solution in NCRT textbook, where the P is partial pressure of the gas, as I said. Chi is the mole fraction of the gas, or you can also say the solubility of the gas. And the KH is Henry's constant. You can clearly see that if the KH value, that is Henry's constant value, is larger for a given pressure, the solubility, or you can say chi, must be small. Okay, because in the relation, the chi and the KH is coming in multiplication or in the product. Okay, so one term, if you take at the another side of the equal sign, then they will be oppositely or inversely proportional to each other. So if one quantity will be larger, another will automatically be smaller. So if the KH value is larger at the given pressure, the solubility must be small, and therefore the higher Henry's constant means that there is a lower solubility of the gas. Okay, so the correct relation depicted by the option is option B for the Henry's constant, which says that if the Henry's constant value is greater for gases, it will be having the lower solubility. Hence, the correct answer is option B. Okay, let's move on to the next one. Okay, this question we have covered. This is a MCQ question and it comes under the NCERT section 1.4 in the solutions chapter. And the question asks that a solution of acetone in the chloroform, what? So from the options you have to select that which condition it is satisfying. Solution of acetone in the chloroform. Okay, acetone is a ketone member and chloroform is our CHCl3. So the four options given are obeys Raoult's law, forms azeotrope, shows a positive deviation from Raoult's law, or shows a negative deviation from Raoult's law. So you have to tell that the solution of acetone in the chloroform satisfies which of the following options. So you have some time, think about it, and then we will continue to the correct answer. Okay, so let's see. So for the given question, the correct answer is option D, which is shows a negative deviation from Raoult's law. So if you talk about the negative deviation means that the intermolecular forces, the intermolecular means the forces between the one molecule and the another molecule. Okay, so intermolecular forces between the two components. Here in this question, the components are acetone and chloroform. So the intermolecular forces between the two components, acetone and chloroform, are stronger than those in the pure components. Pure components means acetone, or chloroform. Okay, they are considered as pure components bonding or pure components you can say intermolecular forces, and the intermolecular forces different between the different components means between acetone and chloroform, you can say A and CH. Okay, so the negative deviation means that the intermolecular forces between the two components are stronger than those in the pure components. So the fewer molecules escape into the vapor phase. Okay, so when the intermolecular forces will be stronger, so the fewer molecules will go to the vapor phase, right? Because they are attaching through the strong attachments and strong forces. That's why a very less amount of molecule will convert into the vapor phase. Now, a solution of acetone in the chloroform shows a negative deviation from Raoult's law, and this occurs because acetone and chloroform form strong hydrogen bonds with each other. Okay, so this is the main reason, which makes the vapor pressure of the liquid or vapor pressure of the mixture lower than the expected from Raoult's law. Okay, so Raoult's law is basically defining Raoult's law we use for defining the relation you know between the vapor pressure of different components. And if you take the solution of acetone in the chloroform, because it will show negative deviation due to the presence of strong hydrogen bond between the acetone and the chloroform, which makes their attraction more stronger than their pure component interaction, which will decrease its vapor pressure. That means lower number of molecules or fewer molecules will escape into the vapor phase, which makes the vapor pressure of mixture lower, which we expected from the Raoult's law. Okay, so that is the whole reason, and the correct answer is option D statement, which says that shows a negative deviation. That means solution of acetone in the chloroform show negative deviation from the Raoult's law. Okay, hence the correct answer is option D. Okay, moving on to the next one. So this question is a MCQ type question, and it is covered under the section 1.6 from NCERT textbook in the solutions chapter. And the question asked that the relative lowering of vapor pressure of an aqueous solution containing a non-volatile solute is 0.0225. The mole fraction of the non-volatile solute is. So the relative lowering of vapor pressure is given, okay, of an aqueous solution which is containing a non-volatile solute. Okay, non-volatile solute means it is you can say high it is quite impossible or quite difficult to convert into the vapor. Okay, so for that kind of solution in which a non-volatile solute is present, the relative lowering of vapor pressure is given as 0.0225. The mole fraction of the non-volatile solute is, so you have to tell the mole fraction of the non-volatile solute. So we have given the four choices. The first one is 0.80, 0.725, 0.15, or 0.0225. Okay, so this question has been into the CBSE exam in 2024 recently. So you got some time, go through it, and after that we will see the correct answer. Okay, now let's see. So for the given question, the correct answer is option D, which is 0.0225. Okay, let's see how. So the relative lowering of vapor pressure for any solution which is containing a non-volatile solute is given by, how can you write that? So basically P naught minus P upon P naught will be equals to the mole fraction of the solute. This solute is a non-volatile solute and it is present in the aqueous solution, and the relative lowering of the vapor pressure is given by this term, which is P naught minus P upon P naught. P naught here is representing the you can say vapor pressure of pure solvent, and P is representing the vapor pressure of the solution, and chi solute is representing the mole fraction of the solute particle. Also, this equation is marked as 1.25 in our NCERT textbook in the chapter solutions. Now, in this equation, we have P naught equals to vapor pressure of the pure solvent, P equals to vapor pressure of the solution, and chi of solute is equals to mole fraction of the solute. Here, the relative lowering of the vapor pressure is given as 0.0225. Right, in the question it is given that the relative lowering of vapor pressure, and this relative lowering of vapor pressure is this term. Okay, we are defining this relative lowering of vapor pressure by this term, P naught minus P by P naught. So if this value is given as 0.0225, the mole fraction of non-volatile solute you have to tell, and this relative lowering of vapor pressure is equal to the mole fraction, so its value will also be equal. Hence the mole fraction of the non-volatile solute will also be 0.0225. Okay, hence the correct answer is option D. Okay, moving on to the next one. This question is a MCQ type question, and we have taken this from the NCERT section 1.7 in the chapter solutions. And the question asks that Vent Hoff factor for the KCl, that is potassium chloride solution, assuming the complete dissociation is. So you have to tell the Vent Hoff factor for a KCl solution, and you are assuming before calculating it, assume that there is a complete dissociation happens. Okay, so this question has been in the CBSE examination in 2024 recently. The four choices or the four options given are 1, 2, 0.5 or 1.5. So you have some time, go through it, and after that we will continue to the correct answer. let's see. So for this given question, the correct answer is option B, that is 2. Let's see how. So the Van 't Hoff factor, which we use to represent by small I, okay. So Van 't Hoff factor indicates what is the number of particles a solute produces in the solution compared to the number of formula units which will be dissolved in the solution. Okay. So Van 't Hoff factor indicates the number of particles which solute can produce in the solution compared to the number of units, the number of its units which will be dissolved in the solution. And we are considering the KCl solution. So for the potassium chloride, which is an ionic compound, it can easily dissociate into the ions, right? It is an ionic compound. The dissociation in the water for the potassium chloride is KCl will dissociate into the K positive and Cl negative, potassium positive and chloride ion. Okay, these are the ions which we will get after the dissociation, or you can say after the complete dissociation of KCl in the water. So what does that mean? This means that each formula unit of the KCl produces two number of ions. One is for potassium ion and one for chloride ion. So the Van 't Hoff factor, that is I for the KCl with the complete dissociation, and this you have to consider because it is already given in the question to assume. So the number of formula unit, the number of ions, or you can say the Van 't Hoff factor for the KCl is I equals to 2 compared to the number of formula units dissolved. There is no formula unit dissolves. Okay, so there is a complete dissociation. So the ions you will get for the potassium chloride will be equals to 2, and hence the Van 't Hoff factor I is equals to 2. So the correct answer is option B. Okay, moving on to the next one. Okay, now this question is a short answer type question from the NCERT section 1.3.2 in the chapter solutions. And the question asks that state the Henry's law and why are the aquatic species are more comfortable in the cold water as compared to the warm water. This also you have to tell. Okay. So this you can see that we have two questions in single question. First of all, yeah, a small tip that as we are discussing CBSE PYQs in the CBSE, you have to write whether it is, if it is a short answer type question, you have to write a short answer for that in some 50 to 80 words. And if it is a long type or very long type, then you have to increase your words and write a long paragraph, or in the points will be more good. Okay, if you write your answer in the points. So you can see that this question has two parts. The first one is state Henry's law, and the second part is that why are aquatic species are more comfortable in the cold water as compared to the warm water. This question has been in the 2025 12th examination, and you have to consider this question. You have some time just to go through it, think about it, what can be the correct answer for this, how can you explain this, and then we will continue to the correct answer. Okay, so let's see. So for this given question, we have the solution given as, first of all, we define the Henry's law. Okay, so Henry's law states that the partial pressure of a gas in vapor phase is proportional to the mole fraction of the gas in the solution. You can also you can clarify it, or you can you can more define it in your way, in your own way. So Henry's law is saying that the partial pressure of a gas in its vapor phase, we represented by P, is proportional to the mole fraction of the gas, that is chi of the gas in the solution. If you remove the proportionality sign, this is basically saying that partial pressure is directly proportional to the mole fraction of the gas in the solution. Now, when you remove this proportionality sign and put an equal to mark, so one constant will come, that constant will be Henry's constant, and the chi g will be same. Okay, so the equation will be P equals to kh times chi of B. Okay, this equation is marked as 1.11 in our NCERT textbook in the chapter solution. So this represents what Henry's law states, that the partial pressure of a gas is proportional to the mole fraction of the gas in the solution, and when you remove the more proportionality sign, there will come a constant, and you name this constant on the name of Henry's, which is Henry's constant. So kh is Henry's law constant. Now we will answer the second question, which is why our aquatic species are more comfortable in the cold water as compared to the warm water. So increase in the temperature decrease the solubility of the oxygen in the water. As you know, water has the formula H2O. Okay, its structure you can consider like this: oxygen and two hydrogen are connecting in this manner. So when you increase the temperature of the water, there will be the decreasing of there will be a visible decreasing of solubility of oxygen in the water. Okay, and as a result, amount of dissolved oxygen decreases. Okay, solubility decreases. That means the dissolvable oxygen in the water will also decrease. That means oxygen content basically is decreased, and it becomes more difficult to breathe as oxygen is less in the warm water, and hence the aquatic species are more comfortable in the cold water than in the warm water. Okay, so highlight is basically that temperature difference cause the oxygen cause, or you can say affect the oxygen solubility in the water, and if there will be no oxygen, it will be difficult to breathe in the water. That's why the aquatic species are more comfortable in the cold water than in the warm water. Warm water contains less oxygen compared to the cold water, and aquatic species feels, or aquatics, it is difficult for the aquatic species to breathe in the warm water. So this is the main reason why aquatic species more comfortable in the cold water as compared to the warm water. Okay, you can also add some another point like how the solubility of oxygen is decreasing, what will be the reaction. You can also add some more points into it. Okay, so this will be the correct explanation for our question, or you can say two question in a single question. Okay, in this question we have used the Henry's law, Henry's constant, vapor pressure, and this concept of oxygen solubility, why aquatic species are comfortable in the cold water. Okay, so let's move on to our next question. So this next question is again a short answer type question. This question covers the section 1.5.2 from our NCERT textbook in the solution chapter. The question says that, first of all, define azeotrophs. What type of azeotrophs is formed by the negative deviation from Rawls law, and give an example. So we have again two different questions in a single question. First of all, you have to define the azeotrophs. What are those? And then you have to tell that what type of azeotroph will be formed by the negative deviation from the Rawls law, and you have to also mention about the example. This question has been into the 2025 CBSE examination. Okay, so you have some time, think about it, try solving it or answer it, and then we will see that what will be its correct answer. Okay, let's see. So for this given question, let's see how can you answer it. So first of all, azeotrophs, because the first question is define azeotrophs. So the azeotrophs are the binary mixture of the solution that have same composition in liquid and vapor phase, and also boil at constant temperature, both. Okay, so Azeotropes are our binary mixture of the solution. Binary mixture means bi means two, so we have a solution in which two mixture are present. So the azeotropes are the binary mixture of solutions, or you can say a mixture having two solutions that have the same composition. They have same composition in the liquid and the vapor phase, and that also they have the same boiling point, or say they boil at the constant temperature, you can say. Okay, meanwhile if you consider other solutions, they will, their components or their mix or their solutions, if any mixture is there, their solutions which is present inside the mixture, the components will be having the different boiling point generally. But in the azeotrope cases, in the azeotropes, the boiling point of the solution present in the mixture is same. Both, or you can say more than both, more than two, they boil at the same temperature. They have same constant boiling temperature. Now, a maximum boiling azeotropes is formed by the solution showing a large negative deviation from Raoult's law at a specific composition. Okay, so maximum boiling azeotrope, they are formed by the solution which shows a large negative deviation from the Raoult's law. As expected from the Raoult's law, this solution or maximum boiling azeotrope will show the large negative deviation as compared to the Raoult's law at a specific composition. If you want to take the example will be 68% nitric acid and 32% water by mass. Okay, these are the examples for such case where azeotropes is formed by the negative division from Raoult's law, which is basically maximum boiling azeotropes. Okay, so azeotropes, first of all, definition that it is a mixture of two or more liquids, boils at constant temperature, same composition in both liquid and vapor phase, right? And they have different, like maximum boiling or minimum boiling azeotropes. We have two different types, and the maximum boiling azeotropes is formed by the negative deviation, or you can say large negative deviation from Raoult's law at a specific composition. And if you want to put the example will be 68% nitric acid and 32% water by mass. Okay, so this will be the explanation, or you can add more points into it as per your choice. So like this you can answer the question. Okay, moving on to our next question. Okay, now this question is a long answer type question, and this question covered, or this question comes under the section 1.6.4 in the NCERT textbook in the solution chapters. The question asks that define osmotic pressure. Why is the measurement of osmotic pressure method preferred for the determination of molar mass of macromolecules such as proteins and polymers? So again we have two, you can say two questions. First of all, a definition, and then a reason based question. So you have to define osmotic pressure, and you also have to tell the reason that why we measure, or why the measurement of osmotic pressure of the, you can say, osmotic pressure method will be preferred for macromolecules like proteins and polymers. Macromolecule means large size molecules, micro means small size molecules. Okay, this question has been in the 2025 CBSE examination, so you have some time, go through it. After that we will continue to its correct answer or the correct explanation. Okay, let's see. So for this given question, we have the solution as, first of all, the osmotic pressure. So osmotic pressure is the extra pressure or the minimum pressure which is applied on the solution to prevent the flow or the internal flow of the solvent into the solution through a semi-permeable membrane. Okay, the minimum pressure which you have to apply to the solution, to prevent the internal net flow, or to prevent the internal flow of the pure solvent into the solution through semi-permeable membrane. That pressure is osmotic pressure. So this is the definition of osmotic pressure. Now the answer of our second question. So in the osmotic pressure method, so we prefer the osmotic pressure method for the measurement of molar mass of the macromolecules. Why? So in the osmotic pressure method, the pressure can be measured at room temperature and molarity of the solution is used instead of the molality. Okay, so in the osmotic pressure method, first of all, we do the measurement at the room temperature. You can say pressure can be measured at room temperature, and also we use the solution's molarity, not the molality. So many macromolecules like proteins, polymers, enzymes, they are unstable at the higher temperature. Why? Because at high temperature they start to denature, they start to convert into its smaller, constituents. Okay. So the macromolecules, or you can say many macromolecules, are unstable at the higher temperature and they have very low solubility. Okay, so the methods like boiling point elevation or the freezing point depression are not suitable for the macromolecules, because here in the boiling point elevation or freezing point depression you will change the temperature, right, which will not be suitable for the macromolecules because they are highly unstable at the high temperature and they have very low solubility at that. So we use the pressure like we use the methods, we can't use the method like boiling point elevation or freezing point depression. They are not suitable for the measurement of molar masses of macromolecules. That is why this method, which is osmotic pressure method, we use for the determination of molar masses of the macromolecules such as proteins, as they are generally not stable at the higher temperature, and polymers have poor solubility at the high temperature. They show poor solubility and they are also not stable. So that is why for the pressure measurement, for the molar mass measurement, we use the osmotic pressure method, because in this method we can measure at room temperature, at the room temperature. Okay, so that means they will be soluble also and they will be stable also. Okay, so yeah, right, that when the temperature will increase, the solubility will decrease for the macromolecules, and this is not in the case of osmotic pressure method. That's why we prefer the use of osmotic pressure method for determining the molar mass of macromolecules like proteins and polymers. Okay, so this is the correct or explanation for this question, for the given question. As I said that you can more explain it or add 1 or 2 points more as per the requirement. Okay, moving on to our next question. Okay, this question is again a long answer type question and it covers, or it comes under the NCERT section 1.6.2 from the solutions chapter. The question says that boiling point of the water at 750 millimeter of Hg pressure is 99.63 degrees Celsius. How much sucrose, whose molar mass is given as 342 gram per mole, is to be added to 500 gram mass of water such that it boils at the 100 degrees Celsius? Now the given quantity is Kb for the water, which is 0.52 Kelvin kg per mole. Okay, so this is the whole question. So what you have to you can say what you have to identify or what you have to determine, you have to determine that how much amount of sucrose is a sugar, how much amount of this sucrose is needed to add to this weight of or this grams of water such that that sucrose or the solution will start boils at 100 degrees Celsius, and the boiling point of water at this pressure, standard pressure, is given as 99.63 degree Celsius. This question has been into the CBSE, in the 2024. So you got some time, try to solve it and think about it, and then we will see the correct explanation and the solution of this question. Okay. Okay, let's see. So for this given question, how can you answer it? So first of all, you have to consider the given quantities, and then you have to think about that in the solution chapter, which is the correct concept which I can or you can relate to it. Okay, which will be the correct concept you can relate this question to, and then under that what will be the correct formula that you can apply to this question. Here we have given that it is covering the section 1.6.2, but in the examination there will be no such information will be provided, right? So you have to relate that which section or which part of the chapter from this question is covering, and then you have to answer. So let's see here what will be the solution. So the delta TB, the change in the temperature is given, it is clearly identified, right? That the boiling point of water is given as 99.63 degrees Celsius, and then we have given some information, and then it is saying that it start boils at 100 degrees Celsius. So we are talking about the change of temperature. So the delta TB, that is change in the temperature of the boiling, is equals to 100 minus 99.63. This will be equals to 0.37 degrees Celsius. This will be the change of temperature of boiling point. Now you have to tell the mass of solute. Okay, you have to tell the mass of sucrose. Sucrose is a solute in the water. Water is a solvent. So what mass of solute, that is WB, you have to identify. Now the mass of water is given, that is WA. The mass of water in the grams is given as 500 gram. And the molar mass of sucrose, this you can calculate simply, right? You just have to know about the formula of the sucrose. If not given, here we have given the molar mass. If in the case molar mass is not given, then you have to learn the or remember the formula of the sucrose, and then you have to calculate the molar mass. Here it is given, so we take the molar mass of sucrose, MB equals to 342 grams per mole. So we apply this formula, which is marked as 1.32 equation in our solutions chapter in the NCERT textbook. So the delta TB, elevation in the boiling point, will be equals to KB times WB upon MB times 1000 upon WA in the grams. Okay, so as the W of A is given in grams, we just divide it by 1000 to convert it into the kilograms. So the KB for the water is also given, the constant, boiling point constant, which is 0.52 Kelvin kg mole inverse, right? So you have to tell the, or what is the variable thing, or what is the thing which we have to find out, that is WB. Okay, so in the formula WB is here. So we take this WB at one side and rest of the quantities at the another side. So WB will be equals to delta TB multiplied by MB multiplied by WA divided by KB into 1000. Okay, so you just have to simply put the values of delta TB, which is 0.37 degrees Celsius, MB, which is 342 grams per mole, WA, which is in grams, which is 500 grams. So converting to grams to the kilogram, we just divided by 1000, and the KB value is also given in the question. You just have to put the values. When you put the value, it will be 0.37 times 342 times 500 divided by 0.52 times 1000. And when you solve this fraction, it will be equals to 121.67 gram, or 121.7 gram. Okay, so if generally it is asked like this, but you can write both 121.67 or 101.7 after the decimal, So this will be the whole explanation or the correct way of answer or solving the question. First of all, you have to write the given quantities what we have given in the question, then what you have to identify, what you have to determine in the question or calculate in the question, and then you start applying the formula. Then you write the formula first of all, that yes, this formula will be applicable or you will used in this question, and then you start rearranging that formula as per the need of the question, and then you put the values, or if you have to find out the value, then you find out the value, then you put the value in the final formula, and then you find out the final answer. So this is the correct way for answering. and hence this 121.67 grams is the answer of this question. Okay, so let's move to the next one. Okay, this question is again a long answer type question, and this covers the NCERT section 1.6.4 in the solutions chapter in the NCERT textbook. The question asks that a 6% solution of glucose whose molar mass is 180 grams per mole is isotonic with 2.5% solution of an unknown organic substance. So we are talking about two solutions. The first one is 6% solution of glucose. The molar mass of this glucose is given, and this solution is isotonic with another unknown organic substance solution, which is 2.5% solution of that unknown organic substance. Okay. Now calculate the molecular weight of unknown organic substance. Now you have to calculate the molecular weight of this unknown organic substance. First of all, we have no clue that what it will be. It is unknown. Okay, so molecular weight determination will be a question, will be a task. Okay, from the given information, this question has been into the CBSE examination in 2024. So you have some time, think about it, try to solve it, and then we see its correct solution and its correct answer. Okay, let's see. So for this given question, so for the isotonic solution, first of all, we are talking that the solutions are isotonic solutions, right? Isotonic solution is the one where the salt concentration is equal to the, okay, so isotonic solutions are salt concentration will be same. That means the osmotic pressure will be same. So osmotic pressure is ICRT, right? C is the concentration. So for the isotonic solutions, the pi1 will be equals to the pi2. Pi is representing the osmotic pressure. Okay, and as I said that osmotic pressure formula will be ICRT, and I is the Vent off factor, and C is the concentration, R is gas constant, T is temperature. Okay, everything is constant, C is a variable, concentration is variable. So if the osmotic pressure is equal for the isotonic solution, their concentration will also be equal. You can say that, right? So we know that pi is equals to CRT, and C is concentration, R gas constant, T is the temperature, and this equation is given as 1.39 in our NCERT textbook in the solution chapter. As R and T are the constant term, R is a gas constant, this is constant, temperature is also constant, because for the isotonic solution we are considering this. So we calculate, or we do the calculation for the isotonic solution as the at the given temperature, at the given constant temperature. So R and T both are constant. Now only variable remains as C and pi, but we know that as they are isotonic solution, so pi will be equal. That means the remaining quantity, which is C, will also be equal. So if you count the C1, the concentration of the first solution, which is given as 6% solution of glucose. 6% solution of glucose means 6 divided by the 180 multiplied by the 1000 divided by 100. Okay, now how you do this? So basically concentration is the molarity and number of moles upon the volume of solution, and 6% solution of glucose is the 6 gram solution in the 100 gram of the 6 gram of the glucose in the 100 gram of the solution. Okay, this is the meaning. So number of moles will be given mass, that is 6 upon the molar mass, which is 180, divided by the volume, which will be the 100, or you can say you divide it by the 1000 for the unit conversion from the gram to the kilograms, or like that, or you can say volume. Okay, so for the unit conversion, we put this formula for the concentration, and when you solve it, it will be some amount, and simply we also put the we also calculate the C2, that is the concentration of the second solution. Second solution is 2.5% of the solution, but it is unknown. We don't know what is the organic substance. So we just put its given weight upon the molar mass, multiply by 1000, divide by 100. Okay. Now you put these two values equal, because the concentration will be equal as the osmotic pressure is equal. So when you put these quantities equal, this term 1000 by 100, this term 1000 by 100, which we use for the solutions unit conversion, and the solution total mass, they just cancel out each other. Okay, because there is a equal to present in between them, so they cancel out. The remaining will be 6 by 180 equals to 2.5 by mb, that is molar mass of the, or molecular weight of the b, that is unknown organic substance. Now you have to simply rearrange this equation, and mb will be equals to this goes here, so this they will come like that, and 2.5 divided by 6 times 180. Okay, so this will be the value for the mb, and when you solve it, it will be equals to 75 grams per mole. Okay, 75 gram per mole. So the molecular weight of the organic unknown organic substance is coming out as 75 gram per mole, and hence this will be the correct answer. So what you have done in this question, first of all, you consider that what is given in the question, then you relate that with the concept you know from this chapter, and then you have to pick up one formula that will be applicable to this question. You write that after correctly matching, and after writing you have to relate something that what is given in the question is given as that the two solutions are isotonic, that means their osmotic pressure will be same, that means their concentration will be same. Then you find out the concentration, and then by putting them, or by putting them equal to each other, you identify that what will be the molecular weight of unknown organic substance. Okay, so this is the whole solution, and 75 gram per mole is the correct answer, yes, for this question. Okay. Okay, moving on to the next one. This question is again a long answer type question, and this covers the NCERT section 1.6.1 in the solution chapter in our NCERT textbook. The question says that a solution is containing 2 gram of glucose. The molar mass is given as 180 grams per mole in 100 gram of water. Now, this is prepared at 303 Kelvin temperature. If the vapor pressure of the pure water at 303 Kelvin is 32.8 mm of Hg, here is missing. Okay, what would be the vapor pressure of the solution? So we are saying that the given mass of the, or the given weight of the glucose, which is 2 gram, a solution is containing this much amount of glucose in 100 gram of water. Water is our solvent. Now they are prepared at this particular temperature, 303 Kelvin. The vapor pressure of pure water, that is the vapor pressure of pure solvent, is given, which is 32.8 mm of Hg. Now you have to identify what will be the vapor pressure of the solution. Okay, so here in this question we are using the vapor pressure constant, vapor pressure concept. Okay, so this question has been into the CBSE in the year 2024. You got some time, go through it, think about this. After that, we will see the correct answer. Okay, let's see. So for this given question, we can first of all write the given quantities. So we have WB, that is 2 gram, the weight of solute. MB, the molar mass of solute, which is 180 grams per moles, it is also given. The weight of solvent is given as 100 gram, that is 100 gram of water. And the molar mass of solvent, molar mass of the water is 18 gram, we all know. Now, the P naught A. What will be the P naught A? The P naught A is the vapor pressure of pure solvent. Okay, that means vapor pressure of pure water solvent. This is given as 32.8 mm of Hg, and this is given at 303 Kelvin temperature, right? So, by the relative lowering in the vapor pressure, if you use this concept, we know that P naught of A minus Ps upon P naught of A, this will be equals to the mole fraction, or you can say this this quantity, which is Wb upon Mb multiplied by Ma upon Wa, right? So the P naught A minus Ps upon P naught A, these are this whole term, as I said previously also, that this whole term is representing the relative lowering in the vapor pressure. Wb is representing the mass of the solute, and Ma is representing the molar mass of solvent, Wa is representing the mass of the solvent, and Mb is representing the mass of the solute. Okay, we use this equation, which is termed as 1.28, given in our NCERT textbook in the solution chapter. Now you just have to put the values which is given. Okay, so the term which you have to calculate in this question is vapor pressure of the solution, which is represented by Ps. The 32.8 is the P naught A. We just put this value here, and it will be equals to 2 upon 180 times 18 by 100. Okay, the given values are already present in our question. You just have to put those values in this formula and you get this equation. In this equation, the only unknown thing is Ps, which you have to which you have to identify. Okay, so you resolve it, or it will be 32.8 minus Ps equals to 32.8 minus 32.8 times 0.002, and this will be equals to 0.0656, and Ps will be equals to 32.8 minus 0.0656. This will be 32.7344. This will be the vapor pressure of solution. So vapor pressure of solution is 32.73 mm of Hg, and this will be the, okay, this is H. This will be the correct solution and the correct answer for our given question. Okay. Okay. So thank you so much for joining the session, and the physics faculty will join you soon, and that is all for the today's chemistry class. Please wait for just some moment. Yeah, you can clear your doubt at the Sathee forum. You can join that by the Zoom live meeting, and the all description is already present in our websites and also in our YouTube channel. You can find that. Thank you.